In this first unit, we're learning how to calculate percent error. In all of our lab investigations, you'll be required to calculate the percent error. It's important that you remember the formula and know how to use it correctly. The formula for percent error is to take the absolute value of the accepted value minus the experimental value divided by the accepted value, and then multiply that times 100. The accepted value is the registered or the book value, the value that is accepted by the entire scientific community. The experimental value is what you get from your data when you do the experiment as a student. Taking the absolute value takes away whether or not your error is an overage or a shortage. In the density activity that we did in class with the blocks, once you determined the mass and volume of the block, you calculated the density. From that, you went to Table 2 and identified which block you had so that you could calculate percent error. So let's do an example of that. Let's say, for example, that in the first part of the experiment, you calculated the density of your block to be 0.59 grams per cubic centimeter, and then with the more refined balance and ruler, you determined that the density was actually 0.48 grams per cubic centimeter. Comparing this data to the table, you could imagine that probably, since you had the solid white block, you could identify it as the Sintra, which has an actual value of 0.51 grams per cubic centimeter. The percent error will be the comparison between the actual value of 0.51 and the experimental value, first using the 0.59 and then second using the 0.48. So I'm going to fill in the equation and then show how that will apply. In the case of percent error, the units will wind up canceling each other out, and our final answer will be stated as a percentage. So we're going to take the absolute value of 0.51 minus our experimental value of 0.59 divided by the actual, again, 0.51. We'll take that answer and multiply it times 100. My calculator gives me a value of negative 0.1568. The absolute value takes away the negative. Multiplying it times 100 will move the decimal 2 places to the right. Then all I have to do is round the answer to the correct number of significant digits, which in this case is 2 significant digits. My final answer is a positive 16%, percent being the unit of percent error. Now let's work out the second one. This time the experimental value is the 0.48. Again, the grams per cubic centimeter cancels from the numerator to the denominator. Our final unit will be percentage because we're multiplying it by 100. Absolute value will take away any negative signs. In this case, our final percent error is 5.9%. So the second instrument gave us a lower percent error than the first one at 16%. A smaller percent error means a higher degree of accuracy. To review, density is calculated by taking the mass divided by the volume. This is a calculation you performed in the lab using the water, and again in the classroom using the blocks. In the lab you had a data table much like this, where you recorded the mass of the water based on the electronic balance, where you write all of the digits just as they display, the total volume, and in this case with the micropipette we were giving that to the nearest thousandth of a milliliter, then calculating density by taking mass divided by volume, as evidenced by the units of grams for mass divided by milliliters for volume. We did this 3 times and took an average to get the average density. Let's look at some sample data. If I were in the lab using the micropipette, my total volumes would have been 1.000 to the nearest thousandth, then 2, then 3, always to the nearest thousandth. My mass recorded will be based on the display on the balance, exactly as it shows. Now I'm going to calculate density by taking mass divided by volume in each case. And I come up with these values for the density. Because I've done this 3 times, I'm going to add those 3 together and divide by 3 to get the average. And my final answer is 1.003 grams per milliliter. Since the accepted value for the density of water is 1.00 grams per milliliter, I can calculate the percent error by comparing the actual value to my experimental value. That would look like this. Remember, we will take the absolute value, which takes away the negative sign, and multiply times 100 to move the decimal over 2 places to the right so that we can state it as a percentage. My calculator tells me that that answer is 0.3%, which is a very tiny percent error, meaning my accuracy was very high. Just to recap, it's important that you know how to calculate both percent error and density. To calculate percent error, you take the accepted value minus your experimental data divided by the actual value, take the absolute value of that, getting rid of any negative signs, multiply that times 100, and state your answer as a percentage. Density is the ratio of mass to volume, mass divided by volume. That is a common characteristic of most matter, so it's important that you recognize it and know how to calculate it. Review this again until you're prepared to calculate on your own percent error and density on the test.